Okay, so here we have another example of finding an antiderivative of a rational expression. And at first glance, this looks like a good candidate for a partial fraction decomposition, correct? Because the degree of this polynomial in the denominator of this rational expression is 3, and the degree of the polynomial in the top is 2. So degree of the bottom is bigger than degree of the top, and that's often a indication that we want to use partial fraction decomposition. But when we look a little bit closer, we're going to notice a couple of things that are going to lead us in a different direction. The really big one here is um, we're not going to be able to easily factor this denominator x cubed plus 3x minus 4. It's not obvious how to factor that, and you really need to be able to do that to carry out the a partial fraction decomposition of this rational expression efficiently. So that's a little bit depressing, right? It looks like we may not be able to find the antiderivative here. But the second thing to notice is, which also is really important, is notice that if you take the derivative of the denominator, x cubed plus 3x minus 4, the derivative of that denominator is 3x squared plus 3. So we have the derivative of the denominator in the numerator, and that is a strong indication, right, that we might be able to integrate this using natural log and substitution. So let's actually try that strategy. So I'm going to let u be x cubed plus 3x minus 4, right? And so, as usual, when we're doing substitution, du dx will compute, and that's 3x squared plus 3, right, which we had already observed a moment ago. And now when we solve for dx, that's easy enough to do. We're going to get dx is going to be du over 3x squared plus 3. So when we make our substitutions, we'll have the antiderivative of 3x squared plus 3 divided by u, right? Because I'm going to substitute u for the denominator here, and then times dx, which is du over 3x squared plus 3, right? And of course, as expected, right, these 3x squared plus 3 expressions cancel with each other, and so we end up with our standard natural log antiderivative, right? The antiderivative of du over u, which we know integrates as natural log of the absolute value of u plus a constant, and then we just simply um, undo the substitution, right? So we have as our final answer here, natural log of the absolute value of x cubed plus 3x minus 4, right? And then plus a constant. So we don't have to use a partial fraction decomposition to find the antiderivative of this rational expression. So remember, you want to look for the easiest technique that you can apply to find an antiderivative, right? Why make the work harder than it needs to be? So you want to be out on the lookout, right, for situations like this, right, which you can actually integrate just using natural log.